Good day, guys. Welcome back to the King's class, and welcome to a new and the last episode under the King series. Now, in today's series, we're looking at this question on board here, right? So, for number one, this would be your assignment at the end of today's class, all right? Now, I'll be using number two as example to show you how to solve this question. Then you'll be using number one as your assignment. So, how do we go about this? We have to show that a raised power m or raised power n equals a raised power m times n for all m and n using the conditions in what? 1 I, and what? I. That is, I'm to show, using these conditions where, a is a positive integer, right, for this. A is a positive fraction, that's for this, and where what? A is negative what? Quantity. Now, for this case, where n would represent what? A positive integer, where n represents what? A positive fraction, and where your n will represent what? A negative what? Quantity. So, how do I then solve for this? Now, the idea is to say that what? For number one, for number 2i, right? Number 2i, to show for what? A positive integer. Now, to show for a positive what? Integer. Now, at this point, for all m and n, using the conditions in what? 1i to I, is to say, given that a raised power m, raised power n, what I'm now saying is to say is the same thing as what? It's the same thing as a raised power m dot a raised power m to what? N factors. That is, when I have this, I'm going to have it also the same as what? A raised power m plus m plus m plus and so on to n. So, for you to understand what I just represented better, is to say, if I have a raised power 2 or raised power 3, for instance now, a raised power 2 or raised power 3, in the first instance, you see is a raised power 2 times 3. Very fast to get your answer. Now, it's also the same thing as saying a raised power 2 dot a raised power 2 dot a raised power 2. That is a raised power 2 plus 2 plus 2 in 3 places. Now, let's prove. If my a was 2, assuming, or if my a was 2, it becomes what? 2 raised power 2 or raised power 3, right? At this point, I have what? 2 raised power 3. 2 times 3 is what? 6. That's 2 raised power 6. I'll get my answer. So, then, or, to apply this method is now to say what? 2 raised power 2 dot 2 raised power 2 dot 2 raised power 2. Which now gives me what? 2 raised power what? 2 plus 2 plus what? Plus 2. Which is still the same thing as what? 2 raised power what? Raised power 6. So when you expand this and expand that, you get the same answer. Now, moving on, from where I stopped. Since I can say a raised power m or raised power n is the same thing as what? A raised power m times a raised power m to the n factor. This now is the same thing as this. By saying what? A raised power m plus m all to n. Alright? So therefore, I can now say that what? A raised power m or raised power n equals to what? A raised power mn. Write that now. As simple as that. So, that's for the first one. For the second one, we have to prove that what? So this 2i, we have to prove that what? It is a positive fraction. So, a positive fraction. Alright? Now, if it's a positive fraction, let's use n to represent the positive fraction, which is the one outside there. So let my n be equals to, let's say, p over q. Alright? This is a fraction and this is positive. If it's a negative, I would have put a negative sign at the front. Alright? Let n be equals to what? P over q. What will I have? I would have my a raised power m or raised power n to be equals to what? a raised power m all raised power what? P over q. Right? Since my n now is what? P over q. So this whole expression becomes this. Now solving it the way we solve this is to say, solving the way we solved I is to say I have a raised power m all raised power p over q. Alright? Now times what? Q. Now what am I doing? Why am I doing this? Why I'm doing this for this instance before I solve it completely is to say that what? Let me make it, a whole number. That is the power of my a raised power m. Let it be what? Whole. So in that case, all I have, this will cancel this out, leaving me with what? A raised power m all raised power p, which is a raised power what? M times p, which is what? A raised power what? mp. To now solve is now see that what? To now solve from here, this initial expression is to see that if I have a base, right, with a fraction as its power. Now, this is like a base. Let's consider the whole in this bracket as what? As a base. If I have a base with a fraction as its power, what I will see is to what? Is to introduce my square root, right? If you've been following us in our solution of indices, introduce my square root, put this base within a raised power m. This denominator, put it outside, but within the square root. That's q. Then this numerator, make it what? The power, which is what? P. At this point, all I have, I'll have it as what? I'm going to have it as what? A raised power m all raised power what? P over what? Over q, if I convert it back. So I can either stop here or bring this one in because it's the same thing. That's going to be what? The square root of what? This is q here, a raised power what? mp. Whichever, I'll get the same answer. Then, finally, I'm to what? Show that it's a negative what? Prove it as what? Negative quantity. So, to prove that what? A raised power m or raised power n is a what? Negative quantity. Can we see that? So, a negative quantity. Alright? So, let n be equals to minus k, assuming. At this point, we have a negative quantity, right? Minus k. So, it implies that what? It implies that what? This a raised power m or raised power n is equals to what? A raised power what? M or raised power what? Minus k. Where my n is now what? Minus k. From here, following my law of indices, when I have a negative power, I would say what? This minus is the same thing as what? 1 all over. So I'm going to have what? 1 all over what? A raised power m or raised power what? K. Where this negative has become what? 1 all over. What remains? A power m times what? K. So which now leaves me with what? It leaves me with what? 1 over a raised power what? mk. Why? I have a power, a base with a power, and another power. So just like what we did here. Alright? So, which now leaves me in indices also as what? A raised power what? Minus mk. So they are still the same thing. To show that what? A raised power m raised power n is the same thing as what? A raised power what? mn. For this, as a positive integer, we got it as what? A raised power mn. As a positive fraction, we got it as what? A raised power what? mp over q from here. And for this, as negative quantity, we got it as what? A raised power what? Minus mk. And that's the solution to this question. So now for number 1 question, how will you prove this? Right? Very simple. For this, assume that this is 1, 1, which in real sense, it's actually x raised power 1, y raised power 1. Now your 1, 1 here represents your m, for this case, to help you easily solve. Your n here represents your n here, right? So follow the same process. and get your answer. See you in my next class.